Hey everyone, today's lesson's on soil pH. But before we start talking about soil pH, let's talk a little bit about the pH scale, which you guys may or may not remember from chemistry or biology classes. The pH scale goes from 0 to 14. Of course, you got 7 in the middle. If a solution has a pH of 7, it's neither an acid nor a base, but it's considered to be a neutral solution. Right? Anything less than a 7, like 6.9 all the way down to 0, is considered to be an acid. Right? Now, if somebody's going to throw an acid in your face one day, right? But you have a choice between like a pH of 6.9 or a pH of 1, right? The better choice would be an acid that has a pH of 6.9 because it's closer to that neutral solution and therefore it's safer, right? Something that's a pH of 1 or 0 is like an acid that would melt your face off of, right? If you have a pH value that's higher than 7, like 7.1 all the way up to 14, you're talking about a solution that's considered to be a base or an alkaline solution, right? What makes an acid is the number of hydrogen ions that are floating around in that solution. These are going to be positive ions, right? A base has something called hydroxide ions, right, which is OH negative. There are always going to be negative ions floating around those solutions, right? Water has equal amounts of positive and negative ions, and therefore is neutral. The other thing that you need to know about the pH scale is that it's based off of powers of 10, which means that's a little bit misleading, right? So if you have two acids, one is a pH of 3 and the other is a pH of 4, right? They may seem like they're similar strengths, but in reality, the acid that has the pH of 3 is much stronger than the acid that has a pH of 4. It's actually exactly 10 times more acidic than pH of 4, right? And then if you have a third acid that has a pH of 2 and you compare it to the acid that has a pH of 4, that pH of 2 is a stronger acid and it's 100 times stronger than the acid that has a pH of 4. Right? So small changes in the pH scale, right, are big differences in how strong an acid or a base is. Basically, every time you move one pH level down, it's like multiplying by 10. Right? Now, if we look at the pH of soil, right, ideally your soil pH is going to be somewhere between a pH of 6 and, even though it says 6.5, really pH of 7 is fine, right? So anywhere from 6 to 7. So that means that most soil's slightly acidic, right? The problem is that a lot of times, so the acid level, the pH level of that soil is getting lower and lower and lower. Therefore, the soil is becoming more acidic over time. The reason why plants don't grow well in acidic soil is because, remember, it's these H+, these positive ions that make an acid an acid. The more acidic you are, the more H+ ions you have floating around in that soil. Also, we said that these clay particles can hold more nutrients than any other soil particle, and that's because this clay particle has a negative charge, and a lot of the nutrients that plants like calcium, magnesium, potassium, all are positive ions, therefore bonded to that clay because opposite charges are attracted to each other. But when you take that same clay particle and now stick it into an acidic soil that has lots of H+ ions, now these little H+, these things that you see here in red, start binding to that negatively charged clay particle. And when that clay particle gets surrounded by these hydrogen ions in this acidic soil, there's no room left for these calcium, magnesium, potassium, all these good minerals to bind to, so they have nothing to hold on to. So the next time it rains, now all of these good nutrients that the plants need from the soil, they just get washed away, right? And that's a process that's called leaching. Right, so that's the removal of dissolved nutrients from the soil, and it's a problem with acidic soils. Right? You can also have a soil that has a very, very high pH. This is a much less common problem. Right? If the pH is too high, it means that things that the plants need, nitrogen, potassium, phosphorus, they don't dissolve well in solutions that have high pH or soils that have high pH. And if they don't become dissolved well, that means the plant roots can't uptake these minerals. There's not too many places that have soils with high pHs. One example I could find was Death Valley in California. We see that it's very, very, very hot here. It's very, very dry, but if you were to take soil out of Death Valley and water it and cool it down and try to grow seed in it, you'd have a hard time growing that plant in that soil, and that's because the pH is 8.5. Fortunately, there's always ways to correct your soil pH, okay? So in like this soil, we could lower the pH by adding sulfur to it. Or if the pH is too low, we could always raise the pH by adding something called lime to that pH, and that brings it up to the appropriate level.